to XSS, Session Fixation, and SQLi. Oh my. I'm Jack Wink. You can follow me on Twitter at _Jack Wink. So a bit about me. I am a software engineer at, oh shoot, I didn't start the beginning of my deck, I'm sorry. Yeah, so I am a software engineer at Duo Security. I've been there for the last year and a half about. I do their mobile apps. We do two-factor authentication. It's pretty cool. You guys should check us out. We got a booth. We're giving out beer coasters and balloons. So check them out. Before my time at Duo, I worked at the University of Michigan as a web developer, making and breaking web apps. I'm still an undergrad there. I love the university. And I'm a bit of a musician, so if you want to talk about that, that's cool too. So I guess, first off, why am I talking about XSS, SQLi, and session fixation? Well, these aren't really new vulnerabilities whatsoever, but you guys still have a problem with them, apparently. According to OWASP, Open Web Application Security Project, the top 10 vulnerabilities as of 2010, number 1 is still injection, whether it's SQL or shell commands. Number 2 is XSS, and number 3 is improper session management. So these are still relevant things to talk about. First off, I'd like to say that transparency is good. I really value transparency in a company. If I'm reporting vulnerabilities to you, I like that you tell me where you are along in fixing it. I've had like CEOs email me 15 minutes after reporting it saying, hey, we fixed the issue. Then their engineering team emails me a couple hours later saying, hey, we're getting started. We need more info. I don't really like that. So just be open, and I'll be a good actor as well. So coming from a web development background, I really like JavaScript. Not really, but it's a good segue into cross-site scripting, which I do love. So cross-site scripting is tricking a client's browser into executing arbitrary JavaScript. So everybody has this mistake. Microsoft, MySpace, Facebook, Twitter. Twitter had like an on-mouse over incident where they broke context and they wormed a tweet. MySpace had like the Sammy worm, which was pretty popular. I friended one dude. He got a couple million friends. But I just mean everyone has this issue. It's easy to slip up and find yourself vulnerable. So the impacts, you can steal sessions. That's not new. You can bypass cross-site request forgery tokens. If you don't know what those are, they're a one-time embedded token, a one-time use token that you embed in your forms. The idea is it prevents you from having a phishing attack from a different website. You can control user data, any kind of API you make. The XSS exploit can execute it via Ajax. But I like to just be annoying with it. I like to turn like the university's directory into something that's a little bit more pleasing. For my viewing, if you're a little bit more sadistic, you could do like JDate or something. So what's the cause of cross-site scripting? You write out user data to the DOM unescaped. So in PHP, it looks something like this. I hope you don't do that. But what if a user submits like a script tag or something like that as part of the post? It gets written to the DOM and executed. But hopefully you know this. This isn't new. The real cause of XSS is actually context. Context is tricky. You've got a whole bunch of different type of data that you want to display, and you want to display it in different parts of your DOM, and you need it encoded as such. So if you're spitting out a string into the middle of an HTML tag, you need to do entity encoding. If you spit it into an attribute tag, you need to do attribute encoding, and you also need to make sure that the attribute isn't vulnerable. And what I mean by that is if you let users submit an href or a source tag, it can be started with perhaps JavaScript : and then the exploit. So you need to make sure that the URLs are valid if you're letting them submit a link. But there's a whole cheat sheet. OWASP provides a really nice guide to this. You can check it out. I've got the links at the end of my slide. And the biggest thing is never trust the input. Variables might change. You might think that a variable is safe, but then your programmers might decide that the variable should come from the user instead. So just always escape data. Microsoft has made this mistake, actually. If you load up their 7.5 IIS web server or before and run it on a non-standard file system, meaning Unix, they relied on the Windows file system to actually protect you from an XSS vulnerability when listing directory contents. Unix, you can name a file as like valid HTML, and it'll load it and execute it. It's kind of a neat thing. Prevention, how many of you guys have seen a slide that looks something like this? Make wrong code look wrong. You've got a naming convention that your developers are supposed to follow to keep you safe. You usually prepend variables that are unsafe with u underscore or something like that. This isn't necessarily bad, but it's hard to make the switch to a coding practice like this if you've already got a developed code base. So let's talk about actually preventing cross-site scripting. You've got three kind of chances to prevent it. You've got the network level, the application level, and the browser level. The network level is pretty cool. I'm not sure how many of you are familiar with Cloudflare, but they kind of sit as a proxy for your website. They take all incoming requests and then decide whether or not they're going to route them to your application. And that gives them a lot of power. They can kind of try to detect cross-site scripting injections. They can detect SQL injections and just drop those packets so it never hits your app. You've also got the application level. Most of you are using some kind of framework like Rails, CodeIgniter, Zend, Django. And a lot of these frameworks have tools that have XSS prevention built in. And lastly, you've got the browser level, which is kind of neat too, which I'm not sure if any of you are familiar with Content Security Policy, or CSP. But it's being developed. Chrome and Firefox have implementations for it under namespaced APIs. And I believe Internet Explorer 10 is actually coming out with it too. So let's take a look at that. Adding content security policy is something that you can do pretty easily. It's as easy as setting a header that your website sends out. You have to move all of your JavaScript from the inline out of the files and into their own separate files that you can load externally. And then you set a policy that says only load script tags from a certain domain. And this will prevent people from injecting you, which I'll show. So if we look at this CSP demo, if we set the CSP, we end up setting the CSP headers. And if you look here, the default source is self, so it'll only load from localhost. Images, it'll load from anywhere. But you've also got media source and script source that you can set policies for. But we'll just kind of set those, and I'll show you the difference. Down here, it's pretty easy. You just print out the post variable, so it's clearly exploitable. And I've got the CSP demo running, so I'll just show you. If I submit my name, whatever. But if you submit, I've got to make some kind of joke relating to the title. So if you inject a script tag and run it without CSP protection, it runs the alert dialog. If we add the CSP protection in and try to inject ourselves again, if you look, it actually, it did get inserted and it does run, or it tries to run, but CSP stops it from executing and protects your users. So if you submit it, you've got an error over here, the CSP warning. So that's something you can do pretty easily for some cheap protection. Now, what if you have to accept HTML from the users? That's kind of an interesting issue. I would suggest going the route of like GitHub and accepting a formatted input like Markdown and then converting it to HTML yourself. If you absolutely have to support HTML, you could look at a library like Google Caja. And what this does is it's an HTML sanitizer and JavaScript sandbox. You can actually let users submit JavaScript and decide what access they have. Something you can check out. And if you want to find out more information about how to properly encode for these different contexts, OWASP has a security API, enterprise security API you can check out. It has all these encoding functions. So let's talk about session fixation. I picked session fixation because it's kind of something that we don't have to think about much. A lot of frameworks handle sessions for you. But even as recently as a couple of years ago, OAuth had an issue with session fixation, one of the earlier drafts. So it is still relevant. The impact, it is an account takeover. It's the same as session hijacking. It's just a type. So you can steal data. You can spy on users, just sit over there and take over the account. But the cause is generally just improper session management. So I kind of want to talk about sessions in general. Session fixation in particular is caused by two different issues. One, I have to be able to set a session identifier, so either through an XSS vulnerability or if you set your session IDs through a get variable, it's possible. And you also have to be persisting the session ID even after a login or reauthentication. So what that kind of looks like, if I'm the attack computer here in red, I would get a valid session ID from the server. I would fixate your session by sending it over either through an XSS exploit, or in this case, it's through the URL. And then you would log in. And since we both know your session ID, I can reload my page with that session, and I've taken over your account. So what that kind of looks like here, if I were to log in to a vulnerable site, you'll see that the session ID is saved up here in the URL. If I can log out and then send off a phishing email to my friend Joe, he'll open up the link, then he'll go to log in. And I've still got this session ID hanging around, so if I reload my page, I am authenticated as Joe. Then I have complete control of his session. If I log out, he's logged out. It's pretty standard. So prevention, first off, you want to use HTTPS. If you don't use that anyways, this is all for nothing. You want to prevent XSS, because I still need a method of changing your session ID. You want to use HTTP-only cookies. Make sure the cookies sent over HTTPS as well. You want to log actions. Anytime you open a session, close a session, change permissions, you want to log that. Of course, don't log the session ID. But having an audit trail is nice, and you can kind of look through these logs later to kind of find malicious-looking activity. But overall, you want good session policy. And what do I mean by good session policy? Just regenerate your session IDs. Renew your session ID anytime the user reauthenticates, or even periodically. You want to require reauthentication on a couple of points. I think Amazon does this really well. If you change permission set, so Amazon, you throw stuff in your cart, you're a regular user, but when you actually go to checkout or change your account, it requires you to reauthenticate because you are now acting with greater permissions than you had. Other things you can consider is a session timeout. After inactivity, 15 minutes or something, you can force the user to log out. Some people will suggest anytime that the user agent changes or the IP address changes that you should force the user to reauthenticate. I wouldn't waste too much time on it. It's more security through obscurity. The IP address, the attacker could be on the same network. The user agent can be spoofed. These aren't things that are going to deter someone from actually exploiting a session fixation vulnerability. So some other things to consider when you're designing a session management system. Session IDs have to have a certain amount of entropy, otherwise they could be brute forced. Most frameworks will handle this for you, but if you're writing your own, just keep it in mind. OWASP recommends 128 bits of length and 64 bits of entropy. And you also have to make sure that your session IDs get escaped. You shouldn't be writing them out to the DOM anyways, but if you're storing them in a database, they are still user-controlled data, so you have to escape them. Don't assume that your system will protect you. That kind of brings me to SQL injection. Is the last vulnerability I'm going to talk about. And your apps need to talk to the database. You have data. You do that through SQL, structured query language. And this is another huge target area. We saw a lot with Anonymous and lulzsec doing massive database dumps. Even recently, LinkedIn, eHarmony, and Yahoo were compromised. So the impact, obviously, you're stealing user data, deleting user data, cracking passwords. Your company's going to get shamed for whatever bad hash function you're using. So make sure you're using bcrypt or scrypt or something of equivalent security. A few notes. Database users, your users probably have a ridiculous set of permissions. I'm not sure when the last time anyone has created multiple users for their database, but you'll end up finding that there's one root user that can add to the admin table, remove from the admin table, and all they use this user for is authenticating regular users to the app. You can cut off a lot of the attack surface just by creating separate users depending on what you're doing. And then a lot of people don't even back up their databases, which is ridiculous. If you lose your data, you want to have frequent backups. So the cause is unfiltered data entering your SQL query. I've seen a lot of PHP code that looks like this, where they just print out a post variable right into the SQL statement. And what happens is someone will submit something like or 1 equals 1, and it will just pull whatever database user it can grab. But the prevention side, you just want to use prepared statements. Almost every language has some form of prepared statements. If they don't have it built in, there's definitely an ORM for the language you're using that will do this. But it kind of looks like you prepare a statement by holding placeholder values in there, and then you bind parameters to them. And you also want to make sure that you're giving your database users minimal privileges. I don't know if you Python people, does anyone use Tornado as a web framework? No? Well, they have an interesting ORM kind of layer. They take in a formatted string and then a set of variables. They'll escape the variables and then they'll format the string. It's very easy to confuse this modulus operator and the comma here. One is vulnerable, namely this. One is not. And if you're designing make it hard for people to do the wrong thing, what I would like to have seen is like this question mark style, where if you end up doing the modulus operator and trying to perform a string comprehension, you'll end up having the code blow up on you. And it's very easy to detect when your code won't run versus when code will run and even pass unit tests. Are there any questions? All right. Well, that's all I have. I've got a whole bunch of links here. I've got other content somewhere else. All right. I'm sorry? Yes, I'll be putting my slides on SpeakerDeck. If you look at my Twitter feed, I'll link it when I put them up. All right, thank you.